Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Fatin Izan Mijom Azari. Today I'm going to present about Laplace equation. The subtopics of Laplace equation divided into three. First, Laplace equation for rectangle coordinate. Second, Laplace equation in cylindrical coordinate. And last one is Laplace equation in spherical coordinate. Let's proceed to the Laplace equation for rectangle coordinate. This is the general equation for rectangle coordinate. Uxx plus uyy equal to 0. And the given is initial and boundary condition. Uxy equal to summation m equal to 1 to infinity am sine m pi over a b minus y sine m pi over ax. Okay, this is the general solution for rectangle coordinate. And we must to determine the constant am by using coefficient of double Fourier sine series. Next is Laplace equation in cylindrical coordinate. The general equation for cylindrical coordinate is del square u over del r square plus 1 over r del u over del r plus 1 over r square del square u over del theta square plus del square u over del z square equal to 0. And the given initial and boundary condition. And general solution for cylindrical coordinate is summation m equal to 1 n equal to 0 to infinity sine gamma n m L minus z jn gamma n m r a n m cos n theta plus b n m sine n theta. And we must to determine the constant am, a and m, b and m by using Fourier's Bessel series. Okay, next is Laplace equation in spherical coordinate. The general equation for Laplace equation in spherical coordinate is urr plus 1 over r, ur plus 1 over r square, u theta theta equal to 0. And the given initial and boundary condition. And the general solution for spherical coordinate is ur theta equal to summation n equal to 0 to infinity r power of n, an cos n theta plus bn sin n theta. And we must to find an, a0 and bn by using this formula. Okay, now let me explain how to prove a Laplace equation in rectangle coordinate. The equation given, the general equation is uxx plus uyy equal to 0. The boundary for x is 0 to 3 and the boundary for y is 0 to 2. First, we must to split boundary condition into two cases, case u1 and case u2. We assume uxy equal to xy, and by using method of separation variable, we must to find second derivative of x and second derivative of y. After we differentiate, we must to substitute to the equation 1, and we rearrange x and y, and we must to equal to the constant, which the constant is p. We will obtain two differential equation, which is x second derivative of x minus px equal to 0 and second derivative of y plus py equal to 0. Let's proceed to the case u1 from equation 4. Okay, when p equal to 0, x double prime minus px equal to 0. And then we get the general equation for x is ax plus b equal to 0. Next, we use boundary condition from case u1. u0 equal to y. Then we substitute to the general equation of x, we will get b equal to 0. The next boundary condition is u3y, and we will get a3 equal to 0. We will obtain uxy equal to 0, which is trivial solution. Okay, when p greater than 0, p is equal to lambda square. X double prime minus lambda square, x equal to 0. We will get the general solution for x is a exponent power of lambda x plus b exponent negative lambda x equal to 0. We use boundary condition u0y, substitute to the x equation, we will get a plus b equal to 0. And use the next boundary condition for case u1, we will get b equal to 0 and uxy is trivial solution. Okay, next, when p less than 0, p is equal to negative lambda square. Solution for x is a cos lambda x plus b sine lambda x. And we use boundary condition u0y equal to a cos 0 b sine 0, we will get a equal to 0. And u3y equal to a cos 3 lambda plus b sine 3 lambda, we will get lambda is equal to n pi over 3. And the general solution for x is bn sine n pi over 3x. From equation 5, we will solve for y equation. When p is equal to negative lambda square, y double prime minus lambda square y equal to 0. And the general solution for y is c exponent lambda y plus d exponent negative lambda y. We use boundary condition of case u1. The boundary condition is ux2 equal to 0. And we substitute to the general solution of y. And we will get c equal to negative d exponent negative 4 lambda. And we simplify it for equation y. Y is equal to cn sine n pi 2 minus y. After all the calculation, we substitute xn and yn to the u equation. And finally, the function is u1 equal to summation n equal to 1 to infinity an sine n pi 2 minus y sine n pi over 3x. Now let's proceed to solve case u2 from equation 5, which is y equation. When p is equal to 0, y double prime plus py equal to 0, and we will get the general solution of y is ay plus b equal to 0. Then we use boundary condition of case u2, which is ux0 equal to 0. We substitute to the general solution of y, we will get b equal to 0. And use the next boundary condition, and we will get a2 equal to 0, and u is equal to trivial solution. Then when p is less than 0, p is equal to negative lambda square. And we will obtain the general solution of y is a exponent lambda y plus b exponent negative lambda y. We use the boundary condition, and we will get u is equal to trivial solution also. When p is greater than 0, p is equal to lambda square. Okay, y double prime plus lambda square y equal to 0, we will get the general solution of y, which is y is equal to a cos lambda y plus b sine lambda y. We use boundary condition of case u2, and the boundary condition is ux0 equal to 0, and we will obtain a equal to 0. And use the next boundary condition, ux2 equal to 0, we will obtain pi equal to n pi over 2. We will get the general solution of y is yn is equal to bn sine n pi over 2y. Okay, now we solve for equation 4, which is x equation. When p is greater than 0 and p is equal to lambda square. X double prime minus x lambda square equal to 0, and we will obtain x equation, which is a exponent lambda x plus b exponent negative lambda x. And we use boundary condition of case u2. We solve for equation x, and since lambda is equal to n pi over 2, and we will obtain equation x, which is an sine n pi x over 2. After that, to find u general solution, we must to add u1 and u2. And we will obtain summation n equal to 1 to infinity an sine n pi 2 minus y sine n pi over 3x plus bn sine n pi x over 2 sine n pi y over 2. Okay, next, from boundary condition case u1, which is ux0 equal to 3, we must to substitute the boundary condition to the general equation for u1, and we will get ux0 equal to an sine 2 n pi sine n pi x over 3 equal to 3. And to find an, we must to integrate from 0 to 3 respect to x, and we solve the integration, and we will get an is equal to 6 1 minus negative 1 power of n over n pi sine 2 n pi. From boundary condition case u2, we use the same method, which is we substitute to the general equation of u2. And the boundary condition is u3y equal to y. And we solve the integration, and we will get bn is equal to negative 4 negative 1 power of n over n pi sine 3 n pi over 2. And finally, we will obtain the general solution of u, which is summation n equal to 1 to infinity an sine n pi 2 minus y sine n pi x over 3 plus bn sine n pi x over 2 sine n pi y over 2. That's all from me. Thank you.